I've got here a variety of computers running all kinds of different operating systems, from a Raspberry Pi, an iPhone, an Intel MacBook, an iPad, a Windows Surface, M1 Mac, and a cheap thin client. And all of these are connected to a virtual session on a terminal server. So how am I able to share one computer amongst all of these users running on all of these different platforms without using virtualization? Come along and find out. The concept we're implementing today is called a terminal server. Long ago, mainframes using time-sharing systems allowed users to share computer resources. Back then, they used teletype equipment as terminals. Incidentally, this is why Unix and Linux named their terminals TTY, short for teletype. As technology progressed, MIT wanted to develop a unified computing environment that encouraged the sharing of ideas, code, and data across all of MIT. They called this initiative Project Athena, and they developed many of the ideas surrounding modern thin clients. This project also included the X window system, a protocol to allow graphical applications to access graphical terminals separated by a network. Fast forwarding to the modern era, Microsoft has supported graphical terminal servers since NT4 and continues to offer a terminal server product to this day, so apparently it's useful enough to some company. We are going to build a Linux equivalent to the Microsoft terminal server, supporting many user sessions at the same time without virtualization. While I won't be expanding on network login today, you could combine this setup with system-wide network authentication such as Kerberos, which incidentally was also developed by Project Athena. Welcome to the server room. So this is the hardware we're using today. We got an AMD Ryzen 5 3400G with 32 gigs of RAM. And we just got our Xubuntu installer, keyboard and mouse, gigabit Ethernet, VGA. And once we're all done, the only thing we're going to need plugged in is going to be the Ethernet power. I've chosen to install Xubuntu Desktop version 21.10, although you can choose any Ubuntu flavor you'd like. I chose Xubuntu since it's a lightweight desktop that I feel is very easy to use. Even though this is a server, I'm starting with a desktop OS, so the entire graphical environment and graphical applications come installed. Depending on your use case, you might want to change the file system here. If you choose None, it'll install on ext4, which is a pretty good install if you're just using it normally. I'm going to choose ZFS instead. So with ZFS, each user will get their home directory on a separate data set, and it'll also create snapshots of the root file system every time it does a software update, and it'll let you roll back to them through the boot menu. So this is a nice feature if you're managing users and want to be able to back up their data sets to TrueNAS or something like that. So now we let this run, and we'll come back when it's all done. So now, because we installed the desktop Ubuntu, we have a graphical user interface instead of a command line. So it's going to pop up with some graphical things we need to take care of. The first one is this language support dialog, and we're going to let it go. The software updater also wants to run, and we're going to tell it to install updates now. Okay, it wants to restart. We're going to restart later, because we're going to have to restart pretty soon anyway. So now we're going to open a terminal, and because it's a server, we probably want to administer this over SSH, so we're going to install OpenSSH. And also xrdp, which is the first remote desktop utility we're going to install. And it actually installs almost everything through this package. The last thing we need is audio support for xrdp, and currently there's a bug in the installer for xrdp's audio that doesn't work correctly with ZFS file systems or NFS home directories. So as a result, I'm not going to put this in the video, but the instructions are in my blog post, and I'm keeping them up to date as I work with the developer on solving this. So now at this point, we can reboot the system, and then we're done using the physical console. We can do everything else remotely. So to understand what's happening here, let's dive into how a Linux graphical program gets its output onto the screen. So any graphical program has a canvas. That's the region within the Windows borders. Windows draw things onto their canvas, such as shapes or text or graphics or whatever the window wants to draw. The output of all of these windows is sent to the window manager, which composites all of them into a single canvas. This composite is then sent to the display server. The display server takes the canvas and interfaces with the appropriate hardware drivers, dealing with multiple monitors, resizing monitors, etc. The video output for each monitor is finally sent to the video hardware, which generates a physical signal to send to the monitors. Now we can inject ourselves at different points in this process to get different types of remote graphical access. To view the contents of a single window, we can redirect it over SSH using X11 forwarding. In this case, a single program is running on the remote system, but the display for that one program is sent to the client. With a terminal server such as xrdp or x2go, we act as the display server. In this case, we create a full desktop environment and window manager bound to our remote session, cutting out the display hardware entirely. Alternatively, we could insert ourselves into the display server and display hardware pipeline and capture the output being sent to the monitor. This is normally how VNC operates, taking over the same session that would normally be displayed on the display hardware. And finally, if we're operating in a virtual machine, then the display hardware is emulated anyways, so we can capture the output of the virtual graphics card and send that over the network. I've done other videos on this topic using Spice for thin clients. So now that we got the system up and running, we should be able to connect to it through a remote desktop. This is the Microsoft Remote Desktop client available from the Microsoft Store. It's also available on Android, on iOS, on macOS. Pretty much every platform has this software available, and it looks pretty similar. So we're going to walk through it on Windows, but it should be the same on whatever platform you're using. So first we have to add a PC. We need the IP address of our terminal server. And we could either tell it to ask every time, or we could add a user account here. I'm going to tell it to ask every time for now. So let's see what that looks like. So now if we double click on it, it tells us it has a self-signed certificate. So because we're not running in a Windows domain and we don't have a public certificate for the server, it is a little bit concerned, but we can click through that. So now we get to log into the VDI system, and this is done by xrdp. So we can use our username and password. And we're logged in. I have a terminal open from when I installed the audio support. So this is our Xubuntu desktop, and we're logged in via Windows. We have access to all of our programs, including a web browser. You can go to my website. It's very functional. I mean, this is running just fine. Web video is not a good experience, so don't try web video. But most applications will work pretty well. So now let's add more users to the system. So we could do that from the terminal if we wanted. So we do sudo add user, we give him a name, alpha. And we need our sudo password. And the full name is what gets displayed on the login prompt sometimes. You could set it, you could not set it, doesn't matter to you. So now we have a username VDI alpha that can log in remotely. How about adding a user from the GUI? Can we do that too? So I got my admin user. I can change my name. So let's add a new user. Another thing to note, so Linux does not allow you to start with a number, and xrdp seems to have trouble if your username ends with a number. Numbers seem to be fine in the middle, but don't put a number on the end. So now we need to set him a password, and the user can change their own password later. There we go. So we got some remote users. Now let's see what it looks like when one of them logs in. So we could log out of our session here and click log out, or we could go up here and just close the session. So now what happens next time we connect to that server? So we get the login screen again. We'll try VDI Bravo. And there we go, they have a session too. So unless we do some more restricting, a lot of these programs here exist for every user, but every user might not be able to use them. So here, if I try to create a new user, it asks me for the password for admin, not for my own user. And that's because VDI Bravo doesn't have sudo permissions, so they're not allowed to make changes. So if you try to make changes, it requires the password for the admin account that does have sudo privileges. So remote users on the system see all of these programs, but can't necessarily use them. So we'll restrict that in a little bit later. So how about if we log in again as the admin? So we're right back to our session we were at before. So when a user closes the session by closing remote desktop, it leaves all their programs open and running. And next time you connect, it reattaches to them. So you could leave Firefox or Terminal or whatever open and come back to it later, and it won't close anything when you log off. What about copying and pasting things? So I got an excerpt from Wikipedia I just copied on my off screen. If I go in here, I create a new text document. Paste it in there. So this got copied and pasted across my session. So the clipboard does work between your remote session. How about copying images? We go over here on my desktop and copy an image. Can I paste it in here? Ooh, must give remote desktop access. Yeah, sure. Let's do that. So remote desktop asks for permission and then closed. So I gave it permission, and let's see if we can copy the clipboard. There we go, we copied an image. How about files? Can we access any files on my remote system? So I got a file on my Windows desktop here, and I want to copy it into the remote session. And it doesn't let me drag and drop, but I can copy and paste. And there you see, my file got copied to the remote session. So now you're all going to ask, what is web browsing like? Let's try YouTube.
Works great. I get a display that resizes itself, I get a keyboard, and I get a mouse. But what I don't get is the ability to take a flash drive or another USB device, plug it into the Pi, and have it show up on the virtual machine. And that's what I'm going to...
So audio works as well. Sometimes it stutters if the video stutters, but it's functional. So what about touch screens? Here we have an iPad. You can see that everything works correctly. One quirk about the iPad is that the mouse does not move to the location of your finger. So if you click your finger onto the touchscreen, it clicks wherever the mouse currently is. So mouse movement is relative. As you drag your mouse across the screen, I'm not necessarily touching where the pointer is, I'm touching somewhere else on the screen and moving at the same distance, which can feel a little bit disorienting, but you get used to it pretty quickly. So here we have a Microsoft Surface tablet, and in this case, the touchscreen does work as expected. Wherever I click my finger is exactly where it clicks the mouse on the screen. So I can click in the corner to close a window. I can drag. You can see the click and drag box shows up. So a slight difference in functionality between clients. Digital security has advanced a lot since the mainframe time-sharing days, and keeping users isolated from each other and from the system as a whole is very important. Running a terminal server like this securely is perfectly within the capabilities of Linux. However, with our current configuration, it's like giving everyone their own account on the same desktop. Each user cannot see other users' documents, but they can all see system files, and it's not hard for them to share files with each other. Whether that's a problem or a feature is up to you. More importantly, RDP is a very commonly targeted protocol. While the protocol, with modern security settings, is secure for the users and does keep user data safe, you will be targeted by attacks and bots trying to guess random passwords. You'll probably also show up on an index of all RDP servers publicly facing on the internet. You should plan on isolating the server to your internal network and using a secure remote access VPN to connect back home. Also, without additional configuration, we haven't limited how much system resources each user could produce. So it's theoretically possible that some rogue user could start crypto mining with all the extra CPU time. We also haven't limited who can log into the system, so anyone that has an account on the computer can log in remotely. Most of these issues can be resolved by locking down things on the server, and I'm going to go into how to configure them now.
To configure session management, we need to go to etc xrdp, and then the file is sesman.ini. So this configures the xrdp session manager, and a lot of the options that we probably want to edit are in this file instead of the xrdp.ini file. The first few options that you might want to consider changing are in the security section here. So by default, allow root login is true, and we're going to set that to false. And that means that the user root can never log in. There's also a line here that says terminal server users equals TS users, and that's the name of a group. So once xdrp is installed, it does not create this group TS users. And so since the group does not exist, any user on the system can log in. But if we create the group TS users and add users to it, then we can restrict who can log in. So let's try that. So we'll add the admin to the list, and who else do we want to add to the list? How about Echo and Foxtrot? So if you want to add someone later, you can go back to Manage Groups, find the TS Users group and click Properties, and click the checkbox for group members here. If you want to do this from the command line, you would use group add. In this case, it already exists, but that would create the group if it didn't already exist. And to add a user to the group, we'd use gpassword. So this should have added our alpha user to group TS users. You can see now VI alpha is checked in this box, so it shows up in both places. So what happens when an unauthorized user tries to log in? I rebooted the server, and let's see if VDI Charlie is allowed to access it. So we get an error here that says login failed for display 0. And so this is what a user will see if they try to log in, but they don't have permissions to log in this system. Takes them back to the login screen. If we hit cancel, it'll disconnect the session. Now that we understand about TS users, there's a few other things we can look at in this file. So restrict outbound clipboard. This sets if you're allowed to copy things from the server to the client on the clipboard. If you're trying to prevent data from leaving the server, this might be a good option to use. Max sessions. This is the maximum number of sessions it'll allow. This doesn't mean your system is capable of this many sessions, and your system might stop allocating more sessions long before then if it runs out of memory. So by default, when you close a remote desktop session, the session will stay open. So the next time a user logs in with that same account, they'll get connected to the already existing session with all of the already running programs. If you set this to true, it will eventually kill all the programs and log the user out. You can set a time to wait before killing sessions, and you can also set a time to disconnect idle sessions. If someone's not using the system but is still connected, it can kick them off. If you'd like the user to be able to log in more than once with the same account, you can set a session allocation policy. The default is to have one session per user. If you try to log into a remote session with the user account of another user who's already in a remote session, it'll kick out the first user and transfer that session to the new user. If you'd like to intentionally create more than one session, you could set this to one of these options here. The most common would be UBI to filter by IP address, or UBC to filter by connection. So by IP address, that means each IP address connecting to the server can have one session at a time. Multiple connections from the same IP address will get handed off to the same session, but multiple connections from different IP addresses will go to different sessions.
And by connection means that a new session is created every single time remote desktop connects. If you're going to use UBI mode, or especially UBC mode, you really need to use kill disconnected sessions. With UBC mode, every time you make a connection to the server, it'll create a new session. So there's no way for you to kill that session or reconnect to it other than killing the process on the server. So something's going on with our system. Someone's trying to use a lot of resources here. And the system has a lot of memory, but someone is still using quite a bit of it. So let's see what's going on. So if we filter by CPU, someone is clearly trying to stress the system here. And it looks like it's VDI echo. So we could nicely ask them not to, or we could try to restrict how much CPU time they can use. How about memory? So our window manager is using a decent amount, which we kind of expect. But VDI echo again here is using 2 gigs just for no good reason. So maybe we want to limit them to 2 gigs per user or 3 gigs per user so they can't monopolize the whole system. The better way to visualize this is by using control groups. There's a tool called systemd cg top, which shows us the usage per control group instead of per process. So right now it looks like user105.slice is using 200% of the CPU and 2.2 gigs of memory. xrdp service is not using a ton at around 2.8%, but if I move my window around a lot, you'll see that xrdp starts bubbling up to the top. So how do we tell who user 105 is? Well, we use the command id. So if we ask id, it tells us that user is 1001. But how do we go from a number to a user? Well, so VDI echo. So VDI echo is the one that's using all of our CPU right now. So in order to bring some sanity to the system, we're going to limit each user to use 200% of the CPU, which is 2 threads, and to use 2 gigs of RAM. So the folder etc systemd system is where we create files and folders to limit control groups. Systemd has a folder structure where we can put configurations of control groups per user. Normally this would be something like etc systemd system user-number.slice.d. So for example, for user 1000, we might create a file in etc systemd system user1000.slice.d, and any .conf files in that folder would be applied to slice of user 1000. However, there's a little trick we can do. If we eliminate the number and just do user-.slice.d, then this folder applies to all users by default if they don't have their own configuration. So we're going to create this folder and create a configuration file in it to limit the default VDI user. So in this file, we're going to put a little bit of configuration that turns on CPU and memory accounting and sets a quota for each one. So here's an example configuration. I've linked in the description below my blog post, which goes into some more detail and links to some resources on systemd control groups. So we're going to save this, and let's see if this applies. I rebooted the system so the changes take effect. We can see here that VDI echo is trying to run a stress test again, but if we go back to CG top, we can see that they're being limited to roughly 200% CPU and slightly under 2 gigs of RAM, just like we asked for. Remember that color manager error we got earlier? We get this error about the color manager device, and we'll deal with that later. It'll pop up from time to time, but here's how we fix that. So we need to create a configuration file for PolicyKit. First, we need to see what version of PolicyKit we're using. In this case, it's 0.105. In newer versions of PolicyKit, we need to create a .conf file which contains JavaScript code for processing the rules. In older versions, we need to use a .pkla file. This version, 0.105, uses the pkla file method. So we need to create a file in the folder etc polkit1 local authority 50 local.d. And we can name it anything we'd like, but we need to make sure it doesn't conflict with anything else. So now we have a pkla file we need to copy and paste the code down from my website into this file. So here's the configuration. It gives any user access to certain color manager permissions. That should get rid of the color manager errors. So now we have a functional terminal server which can be accessed by clients of all different operating systems. Ignoring internet video, this is a pretty good user experience for each client, and it uses a lot less resources than creating a virtual machine for each session. Thanks to Microsoft's wide support for the RDP protocol, we can have access to high-quality clients on pretty much every operating system in existence. Microsoft publishes their client to the Apple Store, the Android Store, for Android TV even, and Samsung even supports RDP access on their Tizen smart TVs. So by using this protocol instead of X-forwarding or VNC, we get better client access. This wide client support makes it a great solution for bring-your-own-device type solutions, where you're relying on potentially arbitrary user-supplied devices that could be running any operating system. While not specifically an advantage of the thin client architecture, keeping all of your computing and data centralized in a server keeps important data off of the end user's devices, which can be a great feature for remote access or for when you're traveling. Be sure to let me know if you liked this video and if you have any other topics on terminal servers you'd like me to cover in the future. Stop going to sleep.